This is your 4.1 note. For your 4.1 notes over exponential functions, you would be required to use your calculator. So go ahead and get your calculator out. On first problem, we're talking about an infectious disease, and it's spreading in a small city of population 10,000. In this specific problem, t represents the time. So the first thing I will do every time I have such a problem, I will start by setting this equation, or by writing this equation into my calculator. So in your calculator, I want you to write that equation. And the equation we're talking about is on the y equal. You go ahead and write by starting alpha y equal, press 1. That's in case you have an updated version. You would put the 10,000 on top, over 5 plus 1245. E, the E button is on the second function. E, I'm sorry, I put ln, is actually second E, and this E is raised to the power of negative 0.97 t. Once you have it on your calculator, the first question on your worksheet says how many people are initially infected at time t equals 0. So from here I can just go to my table, and on your table mine is going by 30. So I will go back to my table set and set it up to the point that it goes by 1. So after 0 I want 1, and I go back to my table. Now it says at t equals 0, I can say that v of 0 is equal to 8. Find the number of affected people after 1 day, 2 days, and 5 days. Let's start with 1 day. In other words, v of 1. V of 1 based on the calculator is 20.966. Of course, you cannot say 20.96 people, because this is the unit here is people. If it's 20.96, we will round it to the nearest whole. That'll be 21 people. For V2, I have 54.37. If I round 54.37, that's approximately 54 people. And the last one, I have V5 is at 678.13. So V5 is nothing other than 678 people. When will 1,500 people be infected? At this point, since we say we're trying to find out when y is equal to 15, in other words, v of t is equal to 1,500. On my calculator, that's what I will have on the y2. I'll put 1,500 here. And once I have my 1,500, I know you may not like zoom 0, but I do like zoom 0. So I will do zoom 0 to have a rough idea of how the graph will look like. And this is what I see for zoom 0. Here's one graph. And the second graph is right here. When will it be 1,500? It will be 1,500 starting at this location. So let's go ahead and write. It will be 1,500. I'll do second trace, 5, enter. The intersection is at 6.8. It means that it will be between two variables. So I would say is between 6 and 7 days. But the exact time is at t equal 6.82. All right, graph the function. Let's go ahead and try to have a rough graph. Based on what I see on my calculator, it will start somewhere here, and it will do something like this. It seems to have an asymptote there, but I can't tell for sure. So I'll just graph it just as I see on my calculator. All right, here's the next problem. This one is for compounded interest. The compounded interest, for the compounded interest, I have A equal P 1 plus R over N to the power of NT. Let's go ahead and identify all our variables. Starting with R. R is actually the rate, and this rate is always decimal. You will write it as decimal. Beside R, we have N, which is N is the number of times per year. Alright, T is the number of years, and P is the principal. What else? We have A. A here is the amount after T years. My handwriting looks kind of funny here. Well, it's the same. A, P, E is the exponential. R and T are the same variables. Let's look at question number 2. How much money will you have if you invest 100,000, actually 1,000 for 3 years? Well, what do I have so far? Here I have $1,000. That's your investment. How much you invest is your principal. So this is my P. For 3 years, that's my T. At an interest rate of 5%. 5% I would say is 0.05. And this one will represent my rate. Compounded weekly. What does compounded weekly mean? And continuously. We have two different ones. Now, if it's compounded interest, yearly, weekly, is this one. If it's continuously, it's this one. So this is the only one for continuously. This equation is only for continuously. So I'll go ahead and start by the one compounded weekly. So this is for the weekly. For the weekly, I will plug into the equation. I will say A is equal to, A is what we're looking for. That will be 1,000 times. It will be 1 plus, my rate here is 0.05, divide by N. How many weeks do we have in a year? We do have 52 weeks. So I will put 0.05 over 52. That I'm raising to the power of 52 times 3. I'll just go ahead and plug it all in my calculator, and once you plug it into your calculator, you will get an approximate value. Of course, it's the dollar amount of 1,161.75. I will show you again what I did on my calculator. I literally plug in exactly what I had on my paper, and this is what I get. So this is in case you do it compounded weekly. Now let's go ahead and do continuously. For continuously, I will say A is equal to, it's still the same 1,000. This time is e to the power of 0.05 times 3. Once again, you can put that on your calculator. So I will do 1,000 e to the power of 0.05 times 3. And my answer here is, once again, it's the dollar amount of 1161.83.